Hi viewers, welcome to chemistry class. We have been discussing alkanol chemistry. We have successfully described two kinds of reactions that alkanols undergo. One, dehydration. Two, combustion. Today we want to look at another reaction of alkanol, which is reaction with metals to form metal alkoxide. Reaction with metals to form metal alkoxide. The general formula for the reaction is alkanol reacting with a metal to afford metal alkoxide plus hydrogen gas. That is the general formula. Alkanol, this is an alkanol, this is a metal. So what this metal does is to replace hydrogen here to form an alkoxide ion which attacks the metal to form alkoxide. Now, we are going to use an alkanol to represent this. We are going to use an alkanol in real reaction. Let's use ethanol. Example, we are going to use ethanol, which is CH3, CH2, OH, plus a metal. Let's use sodium metal. So what we are going to have is sodium ethoxide plus hydrogen gas. So this is an example. But in order to really explain the detailed chemistry of this reaction, we need to talk about the reaction mechanism. The mechanism of the reaction. Mechanism of mechanism of metal alkoxide formation. Mechanism of metal alkoxide formation. Step 1. In step 1, the ethanol in the presence of a base, sodium hydroxide. When in the presence of sodium hydroxide, sodium ion is formed. Hydroxide ion is formed. In water, hydrogen ion is formed. So, another hydroxide ion from water. So, these are the ions that are formed. So, this is a strong base. What happens is that it will cause this is ethanol. It will cause what is called protonation. Let me write this down here. Sodium hydroxide. A proton from the aqueous environment will be produced, and this will be used to protonate the ethanol. And what happens is that the pair of electrons moves into this proton, and we have CH3, CH2, O, H plus. This is an oxonium ion called ethyl oxonium ion. It's an unstable ion. So once this ethyl oxonium ion is formed, it will enter step 2. Step 2 is where ethyl oxonium ion reacts with OH minus from the alkaline environment. So we have CH3, CH2, H plus. So it will react with OH minus, or let's just say plus OH minus. This should be 2 volumes, so that the positive charge here will attract this electron and proton will go. This proton will also go, and join OH to form water and ethoxide ion, CH3, CH2, O. This is the ethoxide ion formed. Ethoxide ion, then plus water. 2 moles of water formed because of this. 2 hydrogen ions reacted with 2 OH ions to form 2 moles of water plus ethoxide ion. Finally, step 3. The ethoxide reacts with Na plus sodium to form sodium ethoxide. Finally, so we have CH3, CH2, O negative plus sodium ion from the sodium hydroxide solution, and we have CH3, CH2, O minus Na plus. This is the sodium ethoxide formed. Sodium ethoxide formed finally. So this is the mechanistic pathways towards the formation of sodium ethoxide. But this reaction is the overall reaction of ethanol with sodium ion to form sodium ethoxide and hydrogen gas. For this overall reaction, in order to explain it in details, we use mechanism of the reaction, where step 1, the ethanol, in the presence of sodium hydroxide, gets protonated to form ethyl oxonium ion. And the ethyl oxonium ion will react with hydroxyl group from the aqueous solution of sodium hydroxide. And here, the two hydrogen ions react with hydroxyl group to form two water molecules with an ethoxide ion. And finally, in step 3, the ethoxide ion attacks sodium ion to form sodium ethoxide. And that is the reaction mechanism.